So our topic of discussion today is vertical projectile motion. We'll start with a prelim past paper, specifically a 2021 prelim past paper, and then move backwards. So we'll see how far we can get. Whatever's not completed today, we'll complete next week, as I believe we have vertical projectile motion for the next 3 sessions, if I'm not mistaken. So let's start. So our first question from a 2021 prelim past paper is question 3. We've got question 3. A boy standing on a bridge projects a ball, or more specifically ball A, vertically upwards with an initial velocity of 15 meters per second. The height of the bridge is 20 meters. Ignore air resistance. So let's highlight a few keywords or important facts from the statement. So the boy standing on a bridge, which means he's on a raised platform, he's not on the ground. So a boy standing on a bridge projects meaning throws an object, more specifically a ball. So this person throws ball A vertically upwards with an initial velocity. So because the ball is not dropped, it is thrown, it has an initial velocity of 5 meters per second. The height of the bridge is 20 meters. So the height from which he throws this object is 20 meters above the ground. States question 3.1. Give the magnitude and direction of the acceleration of ball A as it leaves the boy's hand. So for all my calculations, unless otherwise stated, I am going to assume upwards as positive. You're welcome to assume downwards as positive. That's completely up to you. The choice of direction is your own. So for my calculations, I prefer to take upwards as positive. So any vector quantity that I'm going to deal with within vertical projectile motion will be upwards positive, downwards negative. So our first question, 3.1. Give the magnitude and direction of the acceleration of ball A as it leaves the boy's hand. So when they're talking about acceleration within vertical projectile motion, keep in mind they're referring to G, which is 9,8 meters per second squared. That is the magnitude of the acceleration. Now, let us represent this with a diagram in order for us to figure out the answer to this. So this object was thrown from a height of 20 meters, right? So the object went up, reached a maximum height, and then started to fall down to the ground. Now, during this motion, was the acceleration acting up, down, left, or right? That is what we need to figure out, okay? Because they've stated and direction. So we need to give a direction to that magnitude. So always remember, I know sometimes this can become a confusing question whereby because I've stated upwards is positive, you assume direction is the acceleration is going upwards. That is never the case. Always remember that within vertical projectile motion, when they are talking about acceleration, they are referring to gravitational acceleration. And gravity always acts down. When this ball is thrown, our acceleration acts down. When it's at its maximum height, acceleration is acting down. And when it hits the ground, acceleration is also acting downwards. So throughout this entire object's motion, the acceleration is always going to act down. Always remember that. So the magnitude of our acceleration is A equals 9,8 meters per second squared, and our direction is downwards. Whenever they use the word magnitude, do not include a sign. Okay, so you leave it as a neutral number. There's no positive, there's no negative sign, and that is our answer. Let us move on to question 3.2. Now, question 3.2 states, calculate the total time it will take ball A to reach the road. So keep in mind, ball A was thrown from a raised platform from a bridge that is 20 meters above the ground. It then reached a maximum height and then fell down to the road. So once again, let's represent that as a diagram to help me gain a better understanding of the situation. I always prefer to use diagrams within vertical projectile motion. So let's assume this to be our bridge. I know it looks like a building, but just bear with me. Let us assume it to be our bridge. Now that bridge has a height of 20 meters above the ground or above the road. So this is now our road. And we are going to assume our road as our zero height reference point. Now keep in mind, we had an object that was thrown vertically upwards. So this object was thrown vertically upwards. It went up, 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 reached its maximum height, and then fell down to the road. So it hit the road. That is our object. Let's put in some values so that we can see what we are dealing with. So we were told that this ball was projected with an initial velocity of 5 meters per second. Now, is that going to be negative or positive? Keep in mind the object was projected upwards, and I'm assuming upwards to be positive. Therefore, my initial velocity is going to be positive 5 meters per second. Let's look at my velocity at my maximum height. Always remember that velocity at maximum height is going to be 0. Then let's have a look at the velocity when this object hits the ground or the road. That is what we need to calculate. So we've now identified our initial point and we've identified our final point. In addition to that, we also know that our acceleration is going to be negative 9,8 meters per second squared. Why is it negative? The reason is because I am taking everything that is moving upwards as positive, which means everything going down is negative. And as I've stated in question 3.1, acceleration always acts down. Therefore, my acceleration is going to have a negative value. In addition to that, we also know the displacement of our object. So let's have a look. Our object started at a height of 20 meters above the road. One more thing, I've spelled road wrong for some reason. Let us just quickly fix that up. That is road. Now, let's get back. So our object was initially at a position 20 meters above the road. It then reached its maximum height and then fell down and hit the road. The road being 0 meters. So there's a way that we can calculate that displacement. We have y equals our final height minus our initial height. If you struggle with figuring out whether your displacement is positive or negative, I would recommend using this formula. Because keep in mind, displacement is a vector, which means it can be positive or it can be negative. And if you use the wrong sign, it then means that your calculations are going to be wrong. So keep that in mind. So our final height, which is when it hits the ground, and our initial height, which is when it was thrown. So our delta y, or our displacement, is going to be 0 meters, which is when it hits the ground. That's the final position, minus 20 meters above the ground, which is when it was first projected. Therefore, our displacement is going to be negative 20 meters. That is how we have now found our displacement. Alternatively, if you don't want to use the formula, you can use vectors. How we would use vectors is we'd state we've got a displacement vector going up because the ball moved upwards. Then we have a displacement vector moving downwards because the ball then moved downwards. As you can see, this displacement cancelled out this displacement. So we are only left with this displacement vector. And what is the direction of that displacement vector? It's downwards, indicating negative, and it has a length of 20 meters. Therefore, our displacement is 20, or rather negative 20 meters. So you can choose either or, whether you want to use vectors to identify what's going on, or if you want to use your formula. So we now figured out that we have initial velocity, final velocity, which is what we need to calculate, acceleration, and displacement. So let us write down our formulas and identify which is the best formula that we can use to calculate the final velocity. Let us go back once more and read the question if we are actually calculating final velocity. Calculate, oh, sorry, it's not final velocity, it's time. So we need to calculate the total time it takes for ball A to reach the ground, not final velocity. Sorry about that. So we need to find the total time. So we need an equation that has time in it. Keeping in mind that now, because we are not calculating final velocity, we are calculating time, we can't use final velocity because we don't know that value. So let us write down our formulas to see which is the best one to use. So our formulas are VF equals VI plus A delta T. We've got VF squared equals VI squared plus 2A delta Y. We have delta Y equals VI delta T plus 1 over 2 A delta T squared. And finally, we have delta Y equals 1 over 2 into VI plus VF times delta T. Some people might write the last formula as VI plus VF all over 2, then times delta T. That is the exact same thing. It doesn't really matter. All I've done is factor out my denominator. So let's have a look at our formulas. Let's see which is the best one that we can make use of. Keeping in mind that the only values that we have are initial velocity, displacement, and acceleration, and we need to find delta T. So first of all, what we can do is eliminate any formula that does not have delta T in it, because how can you calculate for time if the formula does not have time within it? So we can eliminate the second formula. It does not have time in it. Next, we can eliminate any formula that has final velocity in it because we do not have final velocity. That means formula 1 and formula 4 gets eliminated. So we now only have delta Y equals VI times delta T plus 1 over 2 A times delta T squared. Keeping in mind that we have delta Y, we have V initial, and we have acceleration. Then we only need to solve for delta T. So that is the formula that we are now going to make use of. So let us do that. So once again, just to summarize what we are doing, we need to calculate the time it takes ball A to go from the time it was projected vertically upwards till the time it hits the road. Keeping in mind that we know the initial velocity, the acceleration, the displacement, and we need to find delta T. So we now have delta y equals vi times delta t plus 1 over 2 a delta t squared. Let us start to substitute. Our delta y is given as negative 20. Our initial velocity is given as 5. Delta t is unknown. And a is given as negative 9,8 times delta t squared. So from here, you can see that we now have a trinomial. So let us move everything to the left and then solve for our trinomial. But before I do that, I'm actually going to simplify my right-hand side a bit. I can multiply a half times negative 9.8. So that is going to give me negative 20 equals 5 delta t minus 4,9 delta t squared. Now I'm going to move everything from the right to the left. That is then going to become positive 4,9 delta t squared minus 5 delta t minus 20. And that is equal to 0. From here, you can put this into your quadratic formula, keeping in mind that your value of a will be equal to 4,9, your value of b will be equal to negative 5, and your value of c will be equal to negative 20. So once you've put that into your quadratic formula, you will then end up with delta t equals 2,59, or delta t equals negative 1,57. So we now have two values for our time. So which is going to be the correct value? We are going to make use of the positive value. Why? Because time can never be negative. Time is a scalar quantity. We can never say I drove to Cape Town and it took me negative 10 hours. You can't have negative time. Therefore, we always proceed with the positive value. Therefore, delta t is going to be equal to 2,59 seconds. And that is it. So I'll zoom out to give you the opportunity to see the entirety of the question. Those that are struggling or those that find one of the parts difficult or need me to explain something, you're more than welcome to unmute yourself, raise your hand and ask your question. Or if you're feeling shy, you can type out your question in the chat box and I will attend to it. So if there's anyone that needs assistance with one of the parts that we've done thus far, please unmute yourself and speak up before we proceed. Okay, so if no one has any questions, let us. Yes, Orabile, you have your hand up. What's your question?
Sir, I don't know if I made a mistake. Can you hear me, sir?
Yes, I'm able to hear you.
But I took downwards as positive, right? But then when I did the working out, I actually got like a math error on my calculator. So I think I might have made a mistake somewhere.
So if you take downwards as positive, right?
Yes, sir.
Just give me a second. So your value of A, did you have it as positive or negative?
I had it as positive.
Okay, that is correct. And then your initial velocity, did you have it as positive or negative?
I had it as negative, sir. I don't know if that's wrong.
No, it's fine, because remember your initial velocity is going upwards and you took downwards as positive. So initial will be negative for you. Then your displacement, did you take it as positive or negative?
So I wrote the negative 20.
So that is the error. Your displacement, keep in mind, your displacement is going down. The resultant displacement. Because remember, you've got part of your displacement goes up and part of it goes down. But the resultant goes down. So if this is your bridge, There's a displacement going up for when the object was thrown up. It then curves and comes down. So see, this displacement cancels out this part of the displacement going down. So you are only left with this. This is your resultant displacement. And that resultant displacement is going down. And remember, you took down as positive, which means your displacement will be positive 20 meters. So that's the error. Just see if you can fix that up, then you should end up with the correct answer.
Okay, thank
So
you,
for
sir.
those that prefer to take downwards as positive, keep in mind, acceleration will be positive, initial velocity will be negative, and your delta y will be positive. Basically, whatever I have, your values will be the opposite. So if I have positive, you'll have negative. If I have negative, you'll have positive. It's always going to be the opposite. So let us proceed if there's no one else with any questions. So our next question is 3.3. So we have calculate how far ball A, or rather calculate how far apart ball A and ball B will be after 1.2 seconds. Patience Larato, you have your hand up. What's your question?
I didn't get to see question 3.1 because I had network problems. So can you please go back to it quickly?
So question 3.1 sometimes pops up and it's usually 1 or 2 marks. It's always just to state what's the direction of acceleration or what's the direction of the net force. Keep in mind, it's always going to be down. Your direction of your net force, keep in mind, when the object is under free fall, is always just gravity. If you have one object, if this is your object and it's under free fall, there's only one force acting on it, which is weight, or some people prefer to call it Fg. That means your net force is acting downwards. If you are asked about acceleration, then it's the exact same thing. The only acceleration that's acting on this object is your gravitational acceleration, which means it's always going to act downwards. Always remember that. And because they've used the word magnitude, if you take upwards as positive, don't write negative 9.8. If you take downwards as positive, don't write positive 9.8. Take magnitude, ignore signs, only put the magnitude, no sign, put a neutral value. If they say magnitude only, leave out the direction. Because they've stated magnitude and direction, put magnitude, then put direction. There was one more person with your hand up. Guys, can you normalize putting your actual names instead of your nicknames? The second person that has your hand up, please can you ask your question?
Hi, I'm so sorry, but you used high negative.
Sorry, I can't hear you.
Okay, can you hear me now?
Yes, I'm able to hear you now.
Okay, I'm so sorry for my username, but
Yes.
Will you please explain to me why you use the height negative 20?
Okay, so the height of negative 20, that's your displacement. So I'll do that on the side. So let's say you've got an object that is thrown from the ground. So let's have a few different scenarios. So if this is your ground level, and you have this object that is projected from the ground, that object will go up, 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 reach a maximum height, and then come down. Please just give me a moment. Okay, now the second scenario about displacement, let's have it projected from a raised platform. So this is our ground. Let's say we have this building and our object is projected from this raised platform. and then it's going to hit the ground. So these are the two situations that we have. These are, in most cases, what you were given. So in situation number 1, your displacement is going to be 0. Why? Because your change in position is the exact same thing. Think about it as if you go to the shop. So if this is your house, this is displacement, okay? Keep in mind displacement and distance are two different things. So if this is your house and this is the shop, right? And the distance between the two is 20 meters. Now for you to go from your house to the shop and then back to your house. So you're going house, shop, house. Your displacement is going to be 0. The reason is because there's no change in position. Displacement refers to change in position. So you went to the shop and then back to your house. Your initial position is the same as your final position. That is why you have a displacement of 0. It's the exact same situation in scenario 1. So your initial height is the same as your final height. So it's 0. Yes. Let us have a look at scenario 2. Now, in scenario 2, we have a raised platform. Now, on this raised platform, we have this person that is throwing an object vertically upwards. Now, let's say this is 20 meters, same as the previous question that we were dealing with, right? Now, when you throw this object, you are throwing it so it travels a distance upwards. Let's say, for example, this is 25 meters above the ground. We don't know what it is because in the previous question, we were not given that height. But let's say, for example, it's 25 meters above the ground, which means that this vector is a 5-meter upwards vector, because from 20 to 25 will be 5 meters up, right? Now let's draw a second vector going down. Now from the top, from the 25-meter point till the ground, that vector has 25 meters on it. Please give me a second. Okay. Now that vector has 25 meters. But which direction is it in? It's in a downwards direction. So we're going to give it a negative 25-meter value. So we've got one vector that's 5 meters up. We've got a second vector that's 25 meters down. If you were to add up these vectors, think of vectors as forces. If we have a 5 Newton force going up and a 25 Newton force going down, how would you get the net force? So let's do that quickly. If you have these two forces, F1 equals negative 5 newtons, and F2 is equal to, sorry, this is positive 5 newtons, and F2 is equal to negative 25 newtons. In order for you to get F net, all you do is you say F1 plus F2, and that gives you 5 minus 25, resulting in negative 20 newtons. That is with forces, which is something that you are familiar with. Now let us take that exact same understanding and apply it to displacement, which is a vector just as force is a vector. So if we have displacement 1, so let's call it displacement 1, that's equal to positive 5 meters. We then have displacement 2, which is equal to negative 25 meters. If we were to find the resultant displacement, all we do is we add up displacement 1 and we add up displacement 2. So positive 5 meters plus negative 25 meters. That then gives us negative 20 meters. That is how we were able to find that negative 20. That is using vectors. But what happens if you do not have that height, that change in height for when it's going upwards? Because keep in mind from the previous question that we were dealing with, question 3.2, we did not have the height from the top of the building to the maximum height. So we need to be able to understand what's going on without using actual numerical values, because it's easy to use numerical values, right? The understanding part is where sometimes we might say, okay, this is kind of tricky. But if we are given values, +5, -25, we can easily just calculate that. But if we need to understand it, that's when it becomes tricky. So the understanding behind this, please give me a second. The student that keeps unmuting yourself, please can you mute yourself? It's kind of disruptive. Okay, now let us go back. We need to understand that there's a distance or a height above that building that the object traveled. So that height cancels one another out. So let us break up this long vector. If we break it at this point, it then becomes -5 meters and -20 meters. So there's two parts to this vector. If we break it up, we now have two parts. So is it not true that the +5 meters cancels out the -5 meters, resulting in only the -20 meter part? That is why I showed you example 1 first, the cancelling out. If you end up at the same position, you've basically not moved. If you go to the shop and then come back home, technically, when we are speaking about distance, you've traveled 40 meters to the shop and back home. But when we are speaking about displacement, you've technically not moved. Your displacement is 0 because your change in position, you've not changed position, so you can't have a change in position. So if we go here, think of what we did in example 1. Look at this. From the time it's projected on top of the building, it goes to maximum height. Then it comes back down to the same position. So that displacement cancels each other out. And we are only left with the leftover -20 meters. Now, if you find this difficult using vectors, I would recommend using a formula. Now, with using the formula, all you need to do is remember that displacement is equal to your change in position. So your first position, or your final position rather, minus your initial position. So when you are using the formula, you need to be able to understand where the position of that object is relative to your reference point. I would suggest making the ground your reference point. It's always the easiest to work with. So if you're working on that notion, your initial position would be on top of the building. Basically, where your initial velocity is, that's your initial position. Where your final velocity is, that is your final position. So if you use your formulas, it's just going to be 0 minus 20, resulting in -20 meters. So irrespective of whether you use vectors or you use the formula, you'll end up with the same answer. But I would recommend using vectors as it's more accurate. Sometimes the formula can be a bit tricky to deal with if you are dealing with different reference points and you struggle with identifying a reference point. But I recommend using your ground as your reference point. Okay, so that was question 3.2 that we completed. Now, question 3.3, let's have a look at that. The student that asked the question previously, you still have your hand up. Do you have another question relating to that? Okay, that's fine. So let us continue. We now have question 3.3. Calculate how far apart ball A and ball B will be after 1.2 seconds. So this, yes.
I don't know how to remove the wave. I'm so sorry.
No problem. It's fine. I'll do it for you.
Thank you.
Now, question 3.3. Calculate how far apart ball A and ball B will be after 1.2 seconds. So this statement is important. We are given time, that 1.2 seconds. This is our time. Next, we are told tennis ball A hits the road below, stays in contact with the road for 0.2 seconds before it bounces up with a velocity of 14 meters per second. So this is also important. So we are given three important pieces of information. We are told that after 1.2 seconds, we need to calculate how far apart these two balls will be. That statement is important because it tells us the time of both balls. Next, we need to understand that when ball A hits the ground, it stays in contact with the ground for 0.2 seconds before it leaves the ground. Then thirdly, we need to understand that ball A leaves the ground with a velocity of 14 meters per second. So let us put all of that information into a graph. Okay, so I'm not going to continue with that one. Let's quickly see if we can redraw one. So we have 3.3. Now, keep in mind, I know my bridge looks like a building, but please bear with me. So that will be our bridge, okay? Assume that to be your bridge. Now, assume this to be your road. And keep in mind, we have a 20-meter high bridge. In addition to that, we know that object A or ball A was projected at 5 meters per second upwards. So let's have that as our initial positive 5. Ball A then goes to maximum height, which is where velocity is going to be 0. Always remember, velocity is always 0 at your maximum height. Next, ball A falls down to the ground and hits the ground. Now, we don't know the velocity with which this ball hits the ground, but what we do know is that this object stayed in contact with the ground for 0.2 seconds. So let's make a note of that. Next, this object rebounded. It left the ground with a velocity of 14 meters per second. So I'll stop my drawing there. So keep in mind, this will be the new maximum height, because after the object leaves the ground, it has to go back up to a new maximum height. Okay. Let's quickly make a note that it rebounded or it left the ground with a velocity of 14 meters per second. Now that is going to be positive 14. Reason being is that the velocity is moving upwards. The velocity with which it hit the ground, that will be negative. So we don't know what it is, but it's going to be negative. So that is what we know so far. Okay, let's look at what information we are given with regard to ball B. So let's just have a key. The blue is going to be ball A. We can make, let's say, red ball B. Okay, so let's see what information we have regarding ball B. Calculate how far apart ball A and ball B will be after 1.2 seconds. Tennis ball A hits the ground below, stays in contact with the ground for 0.2 seconds before it bounces up with a velocity of 14 meters per second. So we are not given any information regarding ball B in question 3.3. Let's see. Okay, here is a statement. I think we've skipped that. At the same instant, ball A is thrown upwards from the top of the bridge. Another ball B is projected from the road. Ball B has an initial velocity of 14 meters per second. So please don't confuse the 14 meters per second of ball A when it rebounds and the 14 meters per second of ball B when it is projected upwards. So keep in mind, ball B is initially thrown with a velocity of 14 meters per second, but ball A bounces off the ground with 14 meters per second. So there's two values of 14 meters per second. One is for ball A and one is for ball B. So let us draw the motion of ball B. So we've got ball B that we'll do in red. Now ball B traveled up, and at some point reached a maximum height. I'll stop my drawing there. Now keep in mind, when you reach maximum height, it's V0. Now ball B was initially thrown with a velocity of 14 meters per second. Because it's upwards, it's positive 14 meters per second. Now, this is the scenario of what's taking place between ball A and ball B. Keep in mind that the time that we are given is 1,2 seconds. In addition to that, we know that our acceleration is -9,8. So we need to calculate displacement. If you are not sure on why I've stated we need to calculate displacement, let's go back to our question and you can see for yourself. The question is calculate how far apart. That statement, how far apart, indicates displacement or distance. If it's stated how long, that indicates time. If it's stated how fast or at what speed or at what velocity, that indicates we are calculating for velocity. So we need to find out how far apart were both balls after 1,2 seconds. So let's do a quick drawing. Let's edit this quickly. So let's state that our ball A, just give me a second to get out blue. So let's state that our ball A was here. So we'll just place it here. We don't know if it was here. I'm just using this as a representation for you to gain a better understanding of what's going on. So let's state that our ball A was at this point at 1,2 seconds. So T is 1,2 seconds. And let's state that ball B, because it's now traveling upwards, let's state that it was here at 1,2 seconds. So this is just for you to gain an understanding. It doesn't mean that the balls were actually at those positions. We have no idea where they were. So let's calculate. So we need to find the distance between these 2 points. So if we extend their positions, we need to calculate the distance between, let us call this delta y. We need to calculate the distance between ball A and ball B after 1,2 seconds. So let's start. Now, we are calculating distance. So let us write down our 4 formulas so we can see which is the best formula for us to make use of. So we have delta y equals vi delta t plus 1/2a delta t squared. We have delta y equals a half vi plus vf delta t. In addition to that, we have vf equals vi plus a delta t. We have vf squared equals vi squared plus 2a delta y. Now, we are first going to have a look at ball A. So we're going to calculate their distances individually. What I'm going to do is I'm going to calculate the distance or the height above the ground of ball A at 1.2 seconds. Then I'm going to calculate the height above the ground of ball B at 1.2 seconds. Once I have those two values, I'm going to compare them in order for me to get the distance between the two balls. So I'm going to repeat that process once more. I am going to calculate the height above the ground of ball A at 1.2 seconds. Next, I'm going to calculate the height above the ground of ball B at 1.2 seconds. Once I'm done with that, I will have both balls' heights above the ground, and I can then calculate. To show you a quick representation of what I'm doing. So this is the bridge, right? My ball A, we've stated, is there. Ball B, we've stated, is over here. I'm going to calculate the height. So let's say this is, let's say it's 10 meters above the ground, ball A. And then let's state that I've calculated that ball B is 5 meters above the ground. Once I've identified that ball A is 10 meters above the ground at 1.2 seconds and ball B is 5 meters above the ground at 1.2 seconds, I'm then going to take, okay, the highest one minus the lowest one, and that'll give me the difference in their height. It means that from ball A to ball B, there is a distance of 5 meters. Okay, that is just an example. It does not mean that it is 5 meters. I don't know as yet. We're going to find out. So keep that in mind. This is just a quick representation of what we are going to do. Let's do step 1. We need to calculate the height above the ground of ball A, keeping in mind that the only values for ball A that we have are the initial velocity, which is 5 meters per second. We have the acceleration, which is negative 9,8 meters per second squared. What else do we have? Let's go back and see. Oh, we have time, hey? Yeah, let us write that. We have time. So keep in mind that we cannot use this 14 meters per second for ball A, the velocity with which it left the ground. The reason being is that we don't know if that velocity is within that 1.2 seconds. We don't know if the ball hit the ground, then 1.2 seconds was completed. We have no ideas yet. So we cannot use the velocity with which it hit the ground, nor can we use the velocity with which it rebounded. Keep that in mind because we don't know if those velocities were within the 1.2 second period. So this is the information that we have regarding ball A. So let us use this information to try and see which is the best formula that we can now make use of. So if we look at formula 1, we need to find displacement. So that is fine. We then need to find, let's see, okay, we're finding displacement. We then have initial velocity, so that's fine. We have time, so that's fine. And we have acceleration, so that is fine. So we can use formula 1. Let's have a look at formula 2. We are looking for displacement, so that's fine. We have initial velocity, so that is fine. But we do not have final velocity. We don't know the final velocity at 1.2 seconds. So we cannot use formula 2. If we look at the third formula, that also has final velocity, so we can't use it. If we look at the fourth formula, that also has final velocity. So basically, any formula that has final velocity in it cannot be used. So let us clear this up. We are going to make use of the first formula only. Formula is delta y equals V initial delta T plus 1 over 2 A delta T squared. Keep in mind that we are finding the displacement of ball A, so I'll label it delta YA. Next, our initial velocity, which is 5 meters per second, times our time of 1.2 seconds, plus 1 over 2, our value of A, which is negative 9,8, times our time, which is 1,2 squared. From there, you can put all of this into your calculator. So once you put all of this into your calculator, you should end up with a height of negative 1.056 meters. Keep in mind that this is not your height above the ground. This is your displacement. It means that the object was displaced 1.056 meters downwards. So let us go and see what does that look like on our graph. If our object was displaced 1.056 meters downwards, keep in mind our object went up for an unknown displacement, then came down. So those two cancelled each other out. So the resultant displacement is what we have, that negative 1.056. So that means that our object traveled 1.056 meters below this height of 20 meters, which means somewhere here. So let us now calculate the height above the ground. In order for us to calculate the height above the ground, we're going to take that value and add it to the 20 meters. So if we have delta YA will then be equal to, so we add that 20 meters to it, and that will then give us, just give me a second to put that on my calculator. That gives us 18,944 meters. That means that our object, more specifically object A, is 18.944 meters above the ground. That negative 1.056 meters, that means that our object was displaced 1.05 meters below where it was initially thrown from. Okay, keep that in mind. So we now know that this object is 18.944 meters above the ground. So let's put that in. So Y equals 19, was it 19 or 18? It was 18, sorry. 18,944 meters above the ground. We now know what the height of ball A is. Next, we need to find the height of ball B. Yes, Tiamo, you have your hand up. What's your question?
Sir, this negative 1.006, I don't seem to understand where it belongs to in the graph.
Okay, so take this 20 as the height of your building, right?
Yes.
Now, this height of your building, that 20 meters, comprises of the height above the ground of ball A and the displacement of ball A. So the reason we have that negative 1.05, just give me a second to double check that value. Negative 1.056. Okay, so the reason that we have that negative 1.056 value, that is the displacement of ball A, meaning that ball A was displaced 1.05 meters below. To make life easier, when I'm explaining this to you, I'll ignore the decimals. I'm just going to state -1, okay? Please bear with me for that. So this ball, this is its origin point. Consider this your reference point for this calculation. Now, this is your initial height, right? This is where you are initially. Now, this ball was projected up, hit maximum, came down. That means that displacement cancels that displacement. So we are only left with what height it came down with. Now keep in mind, I know my drawing is on the 20-meter mark. But remember, that was just a representation for you to get the idea. It's not an exact, it's not drawn to scale. So this object was displaced negative 1.056 meters. That means the resultant vector, remember I was explaining resultant vectors. So if we go back to that resultant vector explanation, where is it? This canceled out this, right? This canceled out this. This negative 20, think of it as negative 1,056. That's my resultant vector of this object. This object was now displaced, so here's our bridge. Went up, 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 down, down, down. This will be more accurate, okay? So this is 20 meters. This is the ground. Think of this as your 20-meter mark, right? Now this object went up, reached maximum height, came down. We know that this displacement cancels each other out, so I'm going to erase that. What are we left with? We're left with this displacement, which is negative 1,056. If we have a total height of 20, I'm using my bridge as a sort of ruler, essentially. So think of it as, you know, when you measure your height against your door to see, I've grown 1 meter, or I've grown 10 centimeters in the last year. So think of it like that. So this ball was displaced downwards from this 20-meter high mark for 1.056. So if we want to calculate the height above the ground of this ball, will we not add the vectors? So we have this vector going up of 20 meters that I'm using as a ruler. And I've got this vector of negative 1.056. So the remainder is the height above the ground. Does it make sense now?
It's clear, sir. Thank you.
Sure. Okay. So keep in mind, the whole goal of this was for me to calculate the height above the ground. That's it. That negative 1.056, that is how much the ball was displaced from its initial position. Its initial position being the top of the bridge. So in your mind, picture this. If you're standing at the top of a building and you throw an object upwards, and that object goes up, 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 reaches maximum height, then starts to fall down. Keep in mind you are restricted to 1.2 meters per second. So the ball is coming down, and after 1.2 meters, pretend as though that ball just froze mid-air. We know that's impossible, obviously, but pretend as if the ball froze mid-air. Where that ball froze will be 1.056 meters below where you are standing. So if you are standing here at the top of this building, this is you. You had the genius idea to throw the ball up and see what happens. So you threw the ball up, went up, then it started to come down. Now, where the ball froze mid-air is 1.056 meters below where you are standing, which is at the top of the building or at the top of the bridge. Now, how would you calculate the height above the ground of where the ball froze? You know that from where you are standing, which is 20 meters above the ground, till where the ball froze, there is a distance of 1.056. So if the total is 20 and you go 1.056 down, what's left over? Think about it like this. If you have a 20 centimeter chocolate and you eat 1.056 centimeters of that chocolate, how much of the chocolate is left? Or if you think about it in the bridge terms, if you, for example, could walk on air, let's pretend we can all walk on air. If you now decided, okay, I'm not going to take the elevator or the lift and go down this bridge and reach the ground, I'm going to walk on air. So you're taking steps down and you pause here. If you stop where the ball is, what's your distance between you and the ground? That's all we're doing. All we needed to do was find the distance between the object when it stopped at that 1.2 second mark, which is negative 1.056 meters below where the person was initially standing to throw the ball. Once we found out the displacement of the object, we were then able to find the height above the ground of that object. Okay. Now, before we proceed with calculating B, is there anyone that doesn't understand what's going on? Is there anyone that's struggling with one of the concepts and needs me to explain? Please speak up now so we can address it before we proceed. Okay, so just give me a second to get rid of all these additional markings so that when I send screenshots, it's easy to follow along. Okay, so we've now found out that our ball A is 18.944 meters above the ground. So when the ball stopped and froze mid-air after 1.2 seconds, it stopped at a height that is 18.944 meters above the ground. Now we need to find out what is the height above the ground of ball B. So let's make a list of the information that we know regarding ball B. So we know that ball B was projected with a velocity of 14 meters per second from the ground, which means it has an initial velocity of positive 14 meters per second. Please give me a moment. I saw that there was a question that popped up. Okay, what paper is this? Okay, Marie, this paper is from a 2021 prelim exam. Now, we needed to calculate the height above the ground of ball B. So we know that ball B was projected from the ground with an initial velocity of 14 meters per second. Because it's moving upwards, I'm going to take it as positive. Keep in mind, I assumed upwards is positive in my initial statement. So for those of you that are still a bit confused, the red writing or the red drawing, that's ball B, okay? So ball B was projected with a velocity of 14 meters per second from the ground. In addition to that, we know that acceleration for ball B is negative 9,8. And the time for ball B is 1.2 seconds. We need to calculate the displacement or the height above the ground of ball B. Now, just as before, I'm basically going to do the exact same thing. So I'm not going to go through the whole process of which formula to use because I'm just copying what I did in ball A's scenario, because I'm just calculating height and I have the exact same known values. So I'm going to use the same formula. So delta y equals V initial delta t plus 1 over 2a delta t squared. I'm calculating the height of ball B, so I'm going to put a little subscript B just to represent that it is ball B. Next, my initial velocity of ball B is 14 meters per second. The time is 1.2 plus 1 over 2 times negative 9,8 times 1,2 squared. From here, all you need to do is put the entire right-hand side into your calculator, and you should then end up with the height above the ground of ball B as 9,744 meters. Above the ground. Something important that you should have realized from this question. If you struggle with your understanding of displacement, you're going to struggle with vertical projectile motion. understand displacement. If you can understand displacement, you basically cut your workload in half. If you noticed, or if you go through a few past papers, you'll see that calculating displacement is a frequently asked question. So I would recommend going in trying to understand displacement. Understand that there's a difference between distance and displacement. Understand that displacement is a vector, meaning it can go up or it can go down. Understand your reference points so that you can make use of them. Like, look at this, for example. If you stop there by negative 1.056, how were we able to understand that that negative 1.056 was the displacement of the object from that 20-meter mark? Is because we understand displacement. If you can understand displacement, you would have been able to get that 18. Keep in mind that if you look at ball A is coming from top to bottom, which means its displacement would have started from that 20-meter mark going downwards. That is why we needed to do the additional calculation of adding 20 to get 18.944. Now, if we look at ball B, it's not going from top to bottom. It's going from bottom to top. It's going up. So because it's going up, we don't need to add 20 because it's starting from the bottom. It's starting from a 0 reference frame. Keep in mind, we've stated that we are going to use the road as our 0 reference point. So from the road to where it stopped, that is the height above the ground. Whereas the displacement of ball A, because it was coming from the sky to the ground, from the top to the bottom, its displacement was from the 20-meter mark going downwards. So that 1.056 only accounted for the height from the distance from the 20-meter mark to where it stopped. It did not account for the height above the ground. That is why we needed to do the additionals. So understand displacement. It will make life easier for you. So let us proceed. We now know that ball A has a height above the road of 18.944. So if we draw this, here's our road, here's ball A, and here is ball B, which is 9.744 meters above the ground. So this is ball B. Keeping in mind, ball A is 18.944 meters. Ball B is 9.744 meters. So we need to calculate the height or the distance between the two balls. So this is what we are calculating. Okay, we need to find that. So how do we do that? All we do is we take the displacement of object A minus the displacement of object B, or the height above the ground of ball A minus the height above the ground of ball B. It's always the higher one minus the lower one. This paper is from a Gauteng past paper. All the prelim past papers that I'll do is from Gauteng unless otherwise stated, but yeah. This is a 2021 prelim Gauteng past paper. So we need to now calculate the distance between the two objects. So we are now going to subtract them. So we'll say displacement will be equal to the displacement of object A minus the displacement of object B. That is then going to give us 18.944 minus 9.744. And if we put this into our calculator, just give me a second. If we put this into our calculator, you should then finally get a value of 9.20 meters. That means that the distance between both balls is 9.02 meters after 1.2 seconds of them being thrown vertically upwards. Keep in mind, both objects were thrown vertically upwards. Now, there is an alternative way of doing this. If you calculated that 1.056 and you did not understand how to get the height above the ground, or you did not want to, there's an additional option that you can use in order to calculate this question. So let's say, for example, I stopped at negative 1.056 for ball A. Let us do that calculation on the side. So I'm going to redo the exact same question, but using a different method. So keep in mind, we calculated the displacement of ball A as negative 1,056. We calculated the displacement of ball B as 9,744 meters. Now, think about it like this. This is our road. We have our bridge, and this ball was displaced. So it was here. It was displaced. So from here to here, that is displacement of ball A. Then we have ball B, which was displaced until this point. This is ball B. And the displacement for ball B, we've calculated it. Now, in order for us to find the distance between the two balls using that negative 1.056, think about it like this. If you have a ruler and you cut your ruler into pieces. So let's say you're writing an exam, everyone needs a ruler. You have two friends that forgot their ruler. Now you're going to cut your ruler into pieces. You'll give one friend a piece, you'll give the other friend a piece, and you'll have a piece and you go write your exam. Okay, for whatever reason. Now, how do we find the distance between the two? So let's say you gave friend A 1.056 of that ruler. You gave friend B 9.744 of that ruler. How much do you now get? All you need to do is subtract those values from the 20-meter ruler. So the total length of your ruler or of the piece that you are using is 20 meters. And you donated, or you gave 1.056 away to friend A, and you gave 9.744 to friend B. What are you left with? So let's calculate that. Let's add up all the pieces and they must equal 20 meters. So we have piece A that you gave to friend A. We have piece B that you gave to friend B, and we have delta Y. Let's call it the piece that you kept. And that is all equal to 20 meters. Now, keep in mind, because we're just adding up and it's equating to a value, we're not going to use the direction. So this is a scalar calculation. So delta A will substitute it as 1.056 plus delta B will substitute that as 9,744 meters plus delta Y, which is the piece that you kept, but we don't know the total. So all you do is move this to the right-hand side. So you end up with delta Y equals 20 minus 1,056 plus 9,744. Now put that into your calculator. So 20 minus 1.056 minus 9.744, and you end up with the exact same value. You end up with 9,20 meters. So irrespective of which method you chose to use or which approach you found easier, you will always end up with the same value. So that is method 2. If you did not want to use the approach of finding the height above the ground for both objects, because keep in mind, method 1 utilized height above the ground. Question 3.4. Question 3.4 states, draw a velocity versus time sketch graph for the motion of ball A from the time that it is projected up from the bridge until the time it rebounds to its maximum height. So we need to now draw a velocity versus time graph for ball A only. We are basically going to ignore ball B. We are only drawing a velocity versus time graph for ball A only. Let's do 3.4. Now, question 3.4, we were asked to draw a velocity versus time graph for ball A. So what information do we know about ball A? Let's go back to question 3.4.1, 2, and 3 to see what we need to include. So they've stated we need to include the initial velocity of ball A. So if we look at question 3.3, our graph, we can see that the initial velocity of ball A is 5 meters per second. But because we are doing a velocity versus time graph, we need to have velocity and we need to have time. So what is the velocity? The velocity is 5 meters per second. What is the time? The time would be 0 seconds. How do we know that it's 0? It's because the initial velocity will have an initial time of 0 unless otherwise stated. Keep in mind our scenario starts at time t equals 0. Unless it's stated maybe ball A was thrown 5 seconds after ball B was thrown, then it won't be 0, it would be 5 seconds. But because they've not stated anything to that effect, we assume it to be t initial equals 0 seconds. So our coordinate t is x and y is v. So we'll have 0 and 5. This is our first coordinate. Time, then velocity. So keep that in mind. So we've now pinpointed our first coordinate. Let's have a look at our next coordinate. What is point 2? Point 2 wants us to indicate the time when the ball hits the road and is in contact with the road. Okay, so this object is in contact with the road for 0.2 seconds. This is the contact time. But it also stated we need to indicate the time when it hits the road. So let's see, were we given that information? A boy standing on a bridge projects ball A vertically upwards with an initial velocity of 5 meters per second. The height of the bridge is 20 meters. Ignore air resistance. Okay, here, look at 3.2. Calculate the total time it takes for the ball to reach the ground. So 3.2 has the answer we are looking for. What is it? Okay, so we now know that it takes 2.59 seconds for the ball to hit the road. So we'll say t equals 2.59 seconds. Because we don't have that velocity, what I'm going to do is I will associate it with just v. So that coordinate will then become 2.59. And I'll just say v because I don't know it. But we can go a step further. We can state whether it's positive or negative v. Let us look at our diagram. If this ball is hitting the ground, and we assumed upwards to be positive, is it not true that our velocity will be negative? Why? Because when it's hitting the ground, it's going from the top to the bottom, from the sky to the road. So top to bottom, it's going in a downwards direction. We said up positive, down negative. So we know that velocity at 2.59 seconds is going to be a negative velocity. Why is that important? It's because we're drawing a graph. Keep in mind a graph has both positive and negative values. So that is 3.4.2. Let's have a look at 3.4.3. What do we need to indicate regarding 3.4.3? We need to indicate the velocity of the ball when it rebounds from the road. So when it rebounds, that is going to be after the 0.2 seconds. So when it rebounds, that velocity was 14 meters per second. So how do we calculate the time when this rebounds? Keep in mind, it hit the ground at 2.59. So let's go back here and try to figure it out. What is the time when it rebound? So it hit the ground at 2.59 seconds. It stayed in contact with the ground for 0.2 seconds. Just give me a second to confirm. Is it 0.2 or 0.02? Let's just double check. Okay, it is 0.2. Okay, that is correct. So it hit the ground at 2.59 seconds. It stayed in contact with the ground for 0.2 seconds. So at what time would it have left the ground? All you do is you add the contact time to when it hit the ground. So add 2.59 plus 0.2, that'll give you the time when it leaves the ground, which is 2.79 seconds. So we now have the time for the 14 meter per second velocity. So it's going to be 2.79 seconds. If we put this into a coordinate, it's going to be x first, which is time. So it'll be 2.79. And then our y value, which is velocity, which will be 14. Keep in mind, it's time, then velocity. So that is it. That is all the important information that we need to show on our graph. Keep in mind that we are not done with the question as yet. We've not actually drawn the graph. So let us now go and draw this graph. So on the side, we'll draw it here. So this is a velocity versus time graph for ball A. Now, let us label our axis. So we know this is going to be our 0 mark. This is velocity, which is meters per second. This is going to be time, which is measured in seconds. Now, before I actually draw the graph, I need a checklist so I know that I've included all the points. So I'm going to do a rough sketch. Now, my ball went hit maximum velocity, and then hit the ground, and then rebounded, eventually reaching a maximum velocity again. So I'm going to tick off as I move through. So this is going to be the initial velocity. This is going to be the maximum height velocity. This will be hits the ground. This will be rebounds from the ground. This will be the second maximum height. So it's just a checklist or a guide for me to say, okay, I've done this, I've done this, I've done this, I've done this. So I don't skip anything. So let's start from the initial. What is the initial velocity and the initial time? Let's have a look. We've already put that into a coordinate. We've got 0 and 5. So let us plot the coordinate 0 and 5. So I'm going to plot that coordinate over here. Let's see, let's make 5 here. So 0 and 5. Let's have this in blue since we previously drew our ball A in blue. So this will be our point. This is the initial point, 0 and 5. So the first part is done. I can tick that off my checklist. The initial, done. Let's now move to maximum height. We know at maximum height, our ball has a velocity of 0, but we don't know the time. So I'm just going to leave it as a random time. I'm not going to specify. So I'm going to put a velocity of 0 at some random time that I don't know. So that's done. Let us check this off. And keep in mind, showing the time for maximum height was not one of the requirements. So it's not important. If you don't show it, or if you choose to calculate it and show it, it's completely up to you. It doesn't matter. Now let us move on to the next point. If we look at our checklist, our next point is when it hits the ground. So let us go and see what is the velocity and time for that. When it hits the ground, okay, here it is, 3.4.2. When it hits the ground, we already have a coordinate for that. But keep in mind, we don't have the velocity. We only have negative v. So it needs to be some negative value that we don't know, but the time must be 2.59. So let us go and put in the time, 2.59. So I'll make 2.59 over here. And then some negative velocity that we don't know. Let's make it negative v. We don't know that. So we plot that coordinate. So we'll plot it over there. That is the velocity with which the ball hits the ground. So let me make this slightly smaller. It looks too big. Okay, so that is the first part. Because keep in mind, the ball rebounds. When an object rebounds, it changes direction. So you need to have a secondary graph. So I've completed my primary graph, my first graph. Let us plot that quickly or connect the points. So this is just from the time the ball is projected until it reaches maximum height, and then finally until it gets to hit the ground. This is when the ball is projected initially. This is when it hits maximum height the first time, and this is when it hits the ground. Okay, that's the first part. So let's go back to our checklist. So we'll tick off when it hits the ground. We are done with that. What's the next part in the motion of this ball? It is when it rebounds off the ground. So let us go back to the information that we were supposed to indicate. So keep in mind, they've stated that we need to indicate that 0.2 second interval for when the ball is in contact with the ground. Keep in mind, that is still under 3.4.2. So all you need to do is just draw another dash, and then you can indicate 2, let's see, what was the time after 2.59? If you add 0.2, I think we wrote it somewhere. Okay, we wrote it down here, 2.79. So that's our time, 2.79. So this indicates that 2 second interval. Now all we need to do is go back and see what is our next point in our graph. Our next point is when the ball rebounds. Keep in mind, it rebounds with a velocity of 14 meters per second. When does it rebound? It rebounds 0.2 seconds after it hit the ground, which is at 2.79. If you go back to 3.4.3, you can see we even plotted a coordinate, 2.79 and 14. So let's go and plot that. We need to now have a 14 on our y-axis. So let's go indicate a 14 over there. Let's have 14 be here, the highest point. So this is 14. So now let's make a point. So from 2.79 to 14, that's about here. So that is when it rebounds. So let's go back to our checklist. We've completed the rebound. What is next? When it reaches maximum height. So let's go. We know that maximum height is when velocity is 0, but we don't have the time when it reaches maximum height. So we just put some random point with some random time. So let's plot that. So we connect it, and that is maximum height for the second time. Keep in mind that you don't need to put the labels. That is something additional that I just did. You don't have to do that, okay?